Okay, page 2/video 2 for week 4. Let's see the FTC number 2, the much more useful one, in action. And let's try to integrate the function negative x squared plus 4x from 2 to 5. What the FTC version base 2 basically says is all you have to do to integrate this is find an antiderivative of this function you're trying to integrate. You plug in 5, you plug in 2, and you subtract the two things. So the antiderivative of negative x squared should be negative 1/3 x cubed, and the antiderivative of 4x, we should bump this x up to x squared, divide 4 by 2, we should get 2x squared. Double check it, just take the derivative real fast. 3 comes down, drops that to negative 1/3 x cubed. Drop that to a 2, we're perfect. 2 comes down, makes that a 4, drop the power by 1, and we're good. Now, notationally, the way we say we're going to plug in 5 and plug in 2 and subtract the two numbers is to put a big giant bar here, put a 5 on the top, and a 2 on the bottom. So next, I just want to plug in 5, and I want to plug in 2, and I subtract the result. So this should be negative 1/3 of 5 cubed plus 2 times 5 squared minus negative 1/3 of 2 cubed plus 2 times 2 squared. Biggest and easiest mistake to make is negative sign errors. So this is the first result when you plugged in a 5, and this is the second result when you plug in a 2, and you're subtracting those two separate quantities. So this should be a negative 125 divided by 3, plus 5 squared is 25, doubled should get you 50, 2 cubed is 8, so this is minus, but really plus, because this negative is going to make this a plus, so this is going to make this plus 8 divided by 3, and that's 2 squared 4 doubled 8, but it's actually a minus 8, because when that negative sort of works its way over here, you're going to wind up with a negative. So I vote we simplify this by putting the fractions with the fractions and the whole numbers with the whole numbers, and then we'll sort it out at the end. So negative 125 thirds plus 8 thirds should be negative 117 thirds. And 50 and negative 8 should make 42. 3 goes into 120, a nice pretty 40 times, so it should go into 117 39 times, so this should be negative 39 plus 42. I believe the answer for this is 3. Now, super important thing, since this is our first ever example of using antiderivatives to do integrals, is the lack of a plus c. And ultimately, what the fundamental theorem of calculus says is that you can use any antiderivative. So I vote we use the antiderivative where c is equal to 0, because it doesn't matter. If there's a plus c here, that same c would have wound up here and here. So when you subtract, those c's wind up canceling anyway. So the nice part about doing the FTC using integrals is the plus c thing just doesn't matter. You can just always choose the plus c, which has a 0 at the end, and then you just don't have to worry about it at all. So there's our first little example. I want to look at a couple more. And there's really one more on this page and then 2 more on the next page. So the second one I want to do is the function 5 over x squared, if I'm not mistaken. 1 over x squared. So I want to do this one. Negative 2 to 4 of 1 over x squared dx. Here's basically it. Instinctively, you probably just pop this up as x to the negative second. You bump the exponent up by 1, divide by new exponent. Again, double check this. Negative 1 makes that a positive 1. Subtract 1 from this. We're good. Notationally speaking, 4 and negative 2 go in there, and then we're good. So this should be negative 4 to the negative first minus negative 2 to the negative first. It's really kind of confusing to look at, but that's our first thing, and that's our second thing. So many negatives. So this is negative 1/4 minus 2 squared, 2 to the negative first is negative 1/2. Now it's now positive 1/2, but then right back to negative 1/2, so this is negative 1/2. And then we get this like negative 1/4 minus minus, this is plus, now back to minus, negative a half minus negative a fourth is negative 3/4. And it's easy to put a box around this and say this is the answer, except it's not. And the reason it's not is 1 over x squared looks like this. And we're trying to integrate from negative 2 to 4. And yeah, that function's not continuous. So one of the parts that's easy to sort of gloss over when talking about the FTC is the continuity of the function. So your function needs to be continuous from negative 2 to 4 in this case. So those are your integration limits. That's where you're finding the area. And that's an unbounded region. We kind of don't know how to do that. It's not closed. So we don't really know how to do that. So this value is just meaningless. You can find an antiderivative and plug in number and plug in a second number and subtract them. That value just doesn't have any significance or meaning if the region isn't closed. If it's an unbounded region, I don't know, that just doesn't really have much value there. So all this work we just did is nonsense. So you could integrate this function from 1 to 10 because the function is continuous from 1 to 10. It's not that it has to be a continuous function over all real numbers, it just has to be a continuous function over the interval you're integrating from. So since 0 is undefined and not in the domain, this function had an asymptote there, and that's just a nonsensical value we just computed. So kind of a waste of our time. So that's it for basic examples with the FTCII. I want to look at 2 other examples on the next video / for page 3 where we actually need a substitution. So that's coming up next.